but I think we'll get into those issues enough today. So I want to just move right on to our first keynote speaker, who's Christopher Hart, the Vice Chairman of the National Transportation Safety Board. We've been hearing a lot about the NTSB in the past year because of the San Bruno incident and their investigation into that and the report that came out in August. And Vice Chairman Hart has agreed to come today and give us kind of an overview NTSB's thing. And I was surprised when he sent me his PowerPoint because I opened it up and I thought it was going to be all about the San Bruno investigation and the recommendations. And it really is not. He's backed up and he's taken a much higher level view of how do we get to safety. And I think that's an appropriate way to start this conference. And everybody's bios are in your packet, so I'm not going to introduce him. Certainly, I think everybody knows Vice Chairman Hart. He was the on-scene coordinator for NTSB in San Bruno. He's got a long history with FAA and airline stuff. And you can read the rest of his bio there, but I'd just like to introduce him and try to find his presentation. Hopefully I can be more successful with that. And there it is. It works. Vice Chairman Hart, let's give him a round of applause.
Good morning. Thank you very much for the opportunity to be here. Carl knows the secret. Any excuse to say hi, Mom, to a camera works for me, so I'm glad to be here. And it's also very appropriate that he started by talking about how to improve safety further, and that's what I'm going to talk about because, as we all know, one of the major impediments to safety programs is the common complaint, it's going to cost too much. It hurts the bottom line. And so I'm going to talk about an aviation industry experience, which is where most of my background is, in which we were able to show that you can improve both safety and productivity at the same time. And this was in a context where we had an accident rate that was coming down wonderfully for a long time and then sort of got stuck on a plateau, and we knew that the accident rate had to get off of that plateau. So this is a tough challenge once the rate gets kind of stuck, how to continue reducing it. So that's what I'm going to talk about, is how to continue reducing, improving safety, reducing the accident rate in some very difficult situations. Now, the conventional wisdom, as we all know, is that if you improve safety, you're going to hurt productivity, and if you improve productivity, you're going to hurt safety. So I'm going to show you a real-world example. This isn't just me talking, but this is a real-world, actual industry example from aviation safety programs that we showed if you do it the right way, because I have to say that if you do it the wrong way, you often will not only improve safety most effectively, but you will often also hurt productivity at the same time. But if you do it the right way, you can improve both safety and productivity, and that's what I want to talk about in the few minutes that I have. And it's not a secret what the process is. Easy to talk about, difficult to implement. The process is system think, and I'm going to tell you what system think is all about, using a system think process and fueling that with information from the front lines about things that are happening every day, what's going right, what's going wrong every day. So that's the key to success, is combining that system think with fuel that consists of information from and about the front line. So here's what I'm talking about when I talk about system think. I'm talking about systems that are complicated and a host of several subsystems that have to work together successfully in order for the entire system to work okay. And in the case of aviation, and I have to think in many of your industries, because I'm not an expert in your industries, but in many of your industries, you're looking at systems that have a lot of subsystems that are coupled sometimes tightly, sometimes loosely, but there's a lot of high-tech innovation going on, so there's a learning curve all the time. And what we see in those situations is that the safety issues are probably not a stovepipe from one of the subsystems, but probably relate to the interactions between the systems. And that's the challenge, is because that means, the good news is it means that the system's sufficiently robust that one thing going wrong probably won't hurt anybody, but the bad news is that means there's no obvious point of intervention to say if we just fixed it right here, we'd fix the problem, because usually the problem relates to the interaction between the various subsystems. And so what that means when you increase the complexity is you reduce the ability to design a system that's not prone to human error. You also create more situations where the person on the front line, the pointy end of the spear, as James Reason would say, encounter situations that weren't even anticipated by the people who design the systems. And last but not least, the people who make the rules and regulations and procedures and processes, they also don't necessarily appreciate all of the ramifications and combinations and permutations of how these subsystems will work with each other. So oftentimes the seasoned operators will say, you know, the rule says if I do it, that I should do it that way, but I know from my own experience, I'm a good person, I'm trying to do the right thing, I'm trying to do it better, faster, cheaper, and I know from my experience if I do it this way, it's actually going to be better. So that's obviously a bad situation, because that means if people aren't following the rules and are accomplishing what they're supposed to accomplish successfully, that's a bad situation. You want the rules to reflect the reality of it, because if people aren't following the rules, and sooner or later, I mean, when it goes right, you pat them on the back, you did great, that's wonderful. But when it goes wrong, you say you didn't follow the rules. Well, if the rule is not appropriate to the situation, then we need to look at the rules instead of just punishing somebody for not following the rules. So the point is, as these systems get more and more complex, we create three opportunities for more human error: less capability to design an error-free system, more likely that the operators will encounter situations not anticipated, and more likely that the operators will see that the rules and regulations and procedures aren't necessarily the best for the circumstance. So in that situation, what we see is people that we put a lot of money into training, they absorb it, they're highly competent, proud professionals trying to do the right thing, but they still commit error. And that's the challenge. Human error will always be with us. So we have to address the fact that human error will always be with us. How can we respond to that reality most effectively? When people are tripping over the step, X times out of 1,000, how big does X have to be before you stop saying you're clumsy and start saying, gee, maybe we ought to pay more attention to the step. Maybe we ought to light it or ramp it or paint it or warning sign or something, but not just you're clumsy, because that does absolutely nothing to help keep the next person from tripping over the step. So if the question is the problem the person or the step, the answer is really that it's not either the person or the step, it's the interaction between the person or the step. It's the interaction between the person and the system that we have to understand better, and the way to understand that better is the information that I'm talking about from the front lines: collecting, analyzing, and sharing information. That's the fuel for this system think process, so we can understand when you make a change in this subsystem, what are the implications of that and what's it going to do to all the other subsystems throughout this complicated system. And the objectives are very simple, twofold: make the system less likely to create opportunities for error, and make the system more able to accommodate error without catastrophic consequence, assuming that there will always be error. You're not alone in this endeavor. The healthcare industry, 1999, this is the report from the Institute of Medicine that estimated somewhere between 44,000 and 98,000 deaths every year, almost 2,000 a week, in U.S. hospitals due to medical mistake. And again, these are good people trying to do the right thing under difficult circumstances. And that's what I see in almost every situation that we address at the NTSB, is good people trying to do the right thing under difficult circumstances. If we see bad people trying to do the wrong thing, those people should be out of the system. And I'm first in line to say that. I'm talking about the inadvertent error committed by good people trying to do the right thing under difficult circumstances. So what we do is we throw away most of the data that we could collect that could help us understand about these frontline interactions, about what's going right and what's going wrong, and we lose most of that data forever, and what we collect is the top of the pyramid, and you've all seen the pyramid. For every fatal accident, you might have 3 or 4 or 5 or 10 or 15 incidents, and might have hundreds and hundreds of unreported occurrences. It's the unreported occurrences that are the building blocks for tomorrow's accidents, and that's what we're trying to learn about, and several industries have started that by looking at near misses, which is sort of the top of the situation, the incidents that didn't quite bend any metal or didn't quite hurt anybody, but could have, but for the grace of God. And a lot of industries are trying to collect that information. But every industry that I've seen has some threshold above which reporting is mandatory. So if it's a fatal accident, in almost every industry I've ever seen, you have to report that. If it's some kind of incident, then somewhere in that incident line is a line below which you only hear about it if people voluntarily report it. And that means they're not going to do that. The frontline workers are not going to voluntarily report it unless they're confident that this report they submit is not going to be used against them, because they are the major source. When we look at accidents at the NTSB, we always hear from the people up front, oh yeah, we knew about that problem. We knew it was going to hurt somebody sooner or later. And that's the real problem, is when they tell you they knew it was going to hurt somebody sooner or later, then you have to ask, well, gee, why didn't we tell somebody and do something about this before it did actually hurt somebody? And there's lots of reasons for that, and I don't have time. As an attorney, I'd be happy to discuss these in great detail offline, but basically these are some of the issues that cause people to be afraid to collect or analyze or share information. Public disclosure, that's for a federal agency like the FAA, that's Freedom of Information Act. People are afraid to report stuff to the federal agencies because they're afraid their name will be in the paper if some enterprising newspaper reporter shows up and says, give me all instances when X, Y, or Z occurred. And next thing you know, somebody's name's in the paper. So that's the last time they ever report anything to the agency, because of the fear of the Freedom of Information Act. When I went to the FAA in '95, one of the first things I did was to spearhead legislation that says if people voluntarily report to the FAA potential safety problems in the system, then it's not disclosable under the Freedom of Information Act. So that was one of the things I did to help address that problem, so people would not be afraid to report potential problems to the FAA, and we have that legislation, and if that would be useful in your industry, I'd be glad to explore that with you and see if that's doable in your industry. Job sanctions, that means if I put the O-ring in wrong and I go to my boss and say, oops, boss, sorry, I put the O-ring in wrong, but look at the maintenance manual, isn't it a little confusing? Boss says, no, it's not confusing, you're fired. Whoops. So the two problems there. One, that's called shooting the messenger. So by shooting the messenger, you pretty much guarantee that never again in life will you ever again see another messenger. Number two, that confusing maintenance manual is out there confusing other people just like it confused me. So that's one of the reasons why at the FAA, when we're looking at the two black boxes you always hear about that come to the NTSB for readout after the crash, we were trying to encourage the FAA, the we that I'm talking about is the FAA, we're trying to encourage airlines to look at that black box after every flight instead of just waiting until the crash. It was obviously designed as an accident investigation tool, so that meant most of the time people only looked at it after the crash. But as long ago as 1970 in the UK, they discovered that if you look at it after every flight, you can learn some really neat stuff about like near misses. What went wrong to almost cause this mishap? Two, even better, what went right to keep this near mishap from ripening to a real deal? So then they started looking at them after every flight and found that this accident investigation tool was actually a very valuable accident prevention tool. Well, in the US, the airlines were afraid to collect that stuff because they say, gee, the more stuff I know that I need to fix, that I haven't fixed, the more it's a liability to me when there's a crash and some lawyer comes to me and says, hey, you knew about it and you didn't fix it. So in order to help encourage the airlines to collect information, the FAA put out a rule, because one of the reasons they were really afraid to collect this stuff is because they were afraid the regulator would knock on the door and say, let me see this information you got, because I'll bet you there's some grist for my enforcement mill. And so the airline said, I'm not going to collect ammunition that you're going to use against me. And so the FAA put out a regulation that says, if you voluntarily collect this information from your flight data recorders after every flight, we will not use it against you unless we see criminal or intentional wrongdoing. Short of that, we will not use it against you, but the whole industry can use it and learn from it. Again, this is the information from the front line, so that was the solution to that problem, was to guarantee that absent criminal and intentional wrongdoing, this information will not be used against the airline that collected it. Criminal sanctions, that's a big issue. I could spend a whole session just talking about that. Concorde accident's a great example of that. Mechanic for Continental Airlines did something wrong, piece fell off the airplane onto the runway, Concorde after it, hit that piece that's on the runway, tire shreds, piece of the tire into the fuel tank. The rest is history. Concorde mechanic is facing criminal charges. Now, where I went to law school, you have to want to hurt somebody before they talk about criminal charges. This guy probably made an inadvertent error, and we'll never know the details. Once they punish, the usual result after they punish somebody is they say, well, we took care of that. We don't need to look any further. Well, we need to look further because we have to wonder, did he have the right tool? Did he have the right inventory, the stuff he needed in inventory? Was the lighting correct? Was the situation correct? All the systems issues in which this person was probably trying to do the right thing are now ignored, so that means those system issues are out there, so maybe somebody else can make that very same mistake because once they punished, they said, okay, we took care of that problem, don't need to look any further. Well, that's a huge issue, and that's why criminal sanctions are appropriate under certain circumstances, but if they're used overzealously, they can have a huge effect undercutting improvement of safety. So we have to be very careful about using that very powerful tool, just like any other powerful tool. It has to be used carefully. Used appropriately, it's wonderful. Used inappropriately, it can have harmful results. The big issue in the U.S., civil litigation, people just afraid all this information is going to be used against them if they collect it. So we have to address that. Do you want to answer to the jury, why didn't I know about that problem? Is it because I collected the information, but I wasn't smart enough to know what to do with it? Or is it because I decided intentionally I'd rather not collect the information because I don't want to know about the potential problems that I don't have resources to fix? And that's a decision that every company has to make on their own. So I can talk to you again, I can talk to you about that at great length. Don't have the time to do it this morning, but what I'd like to say is that we are making very good progress on all of those issues, so much so that we started running into what I call a cultural barrier, which is the boss is on the media, safety first, but the person on the floor, who sometimes can get hurt by their mistakes, their first interest is in pleasing their boss because their boss is the one that determines their career progression, their salary increase, and then they're going to think about safety. Well, guess what their boss wants more often than not? Their boss's job goal is production, getting stuff done, getting stuff finished, not safety. So as long as the middle management has a productivity metric but no safety metric, then when the person from the floor comes to that person, comes to middle management and says, I've got a potential safety problem, middle management says, well, wait a minute, that's not part of my metric. I care about productivity. If what your problem is going to hurt my productivity, don't bother me with it, go fix it. And that means that no matter how strong the person at the top talks about safety, no matter how strong the person at the bottom wants safety, it gets stuck in the middle unless there's a safety metric in middle management. We see that everywhere. This isn't just industry. We see it in government, air traffic controllers. We see it all kinds of places. So this is a very common issue that we see, that safety gets stuck in the middle because there's no safety metric for middle management. Now, having said that, we're making great progress on all of these issues to the point that we're starting to get a major, major flow of information from the front line, and that's creating new problems for us because now we got to decide what do we do with all this stuff. We got a lot more stuff, information, than we have capability to use. And that's a big challenge, so much so that some of the airlines are saying, why should I collect it? I already know about more problems than I can fix, and you're coming to tell me how to develop a program to learn about even more problems that I won't have resources to fix. Why should I do that? So our challenge is to get smart enough to know what to do with this flood of information that we're collecting, to do smart things with it, collecting lots and lots of data from lots and lots of sources, mostly the front line, and applying very sophisticated tools and processes to all of that data to do 4 things. First is identify what the problems are. 2 is to prioritize, because I assure you any robust program at all is going to tell you about more issues than you're going to have resources to fix. So you have to get smart about front burner, back burner. Number 3, decide how you're going to solve, what the intervention is for that problem that you put on the front burner. And number 4 is evaluate whether that solution is working without creating unintended effects. So those are the 4 challenges of using this large quantity of data to fuel the system think process. Here's the success story. In the mid-90s, after that accident rate had leveled off to a plateau, but the FAA was projecting a doubling in commercial flying volume, simple arithmetic tells you a flat rate times a doubling volume means the public is going to see smoking holes on CNN twice as much. And that scared a lot of very progressive safety thinkers in aviation. And they said, we got to do something about this. And to paraphrase Einstein, we keep doing what we've been doing, we're going to keep getting what we've been getting. And what we've been getting is that flat rate. So how are we going to get out of the box and reduce that rate ever further? Because it doesn't satisfy the public when they're seeing yet another smoking hole on CNN. Doesn't satisfy them to say, don't worry, the rate is real low. That's not helpful. They got to bring down the number of events, not just the rate. So that's the challenge. And how did they do that? They did it by system think fueled by information from the front lines. And this was amazing enough that they reduced the accident rate by 65% in only 10 years. That was amazing enough in and of itself, but it was even more amazing because the accident rate that they reduced it from was already considered very low. So this was a huge, huge success story, and the way they did it was with the system think. Now, the system think meant, you can have a very, very, very smart person who understands that if you make this change in this subsystem, it'll do all these other things to these other subsystems, or you can bring the subsystems all to the table to talk together, to work collaboratively. So the word I'd like to leave with you today is collaborate. To work collaboratively, the airlines, the manufacturers, the air traffic organizations, labor, the regulator had to be there, all of those organizations working collaboratively to look at these problems, to identify, prioritize, solve, and evaluate. And the collaboration is the crucial element. And let me tell you why that's so different. Because back in the old days in a regulated industry, the regulator would would say, I see a problem, and here's the solution I'm going to propose for the problem. So they put out a notice of proposed rulemaking that tells what the problem is they see and what the solution is. And then the industry says, hey, FAA, you never flew an airplane. You don't understand how I do business. I don't have a lot of faith in your identification of the problem, and I'm even less sanguine about your identification of the solution for this problem. So I'm going to fight it, and I'm going to litigate it, and I'm going to struggle not to do it. And to the extent I do it, I'll do it begrudgingly, et cetera, et cetera. You've all been there, done that, seen what I'm talking about. Well, here's the new situation. Now it's collaborative. So now everybody is at the table together, identifying, prioritizing, solving, and evaluating. So here's the difference. Back in the old days, you put out the NPRM, you hear what A thinks about your NPRM. You hear what B thinks, you hear what C thinks. What you don't hear is what A thinks of what B and C think. That's what you hear in the collaborative process. That's the system think, that now the regulator is still the regulator. This is not a democracy. The regulator still must be the regulator. The regulator still does that, but now the regulator has a much richer source of information about what the impacts of this will be, because the system think is now part of the process, because they're hearing what A thinks of what B, C, and D think. So now everybody in the process, by the time a solution emerges from this, Everybody's interests have been considered, and everybody understands everybody else's situation. So by the time something emerges from this process, everybody is on board with it, they have an ownership interest in it, and they do it willingly. So not only is it a more effective safety solution, but the likelihood of creating unintended results is diminished almost to zero. That's really exciting. So now they're promptly, willingly implementing this. This is how they achieved a 65% reduction in an industry that complicated in only 10 years. And by the way, this process did not generate a single new regulation. Wow, that was exciting. That was exciting. This is the safety story, the success story that I would commend to other industries. I'm not saying that one size fits all, because maybe it doesn't, but I would say there's enough similarities that we can learn from these processes and see what worked and what didn't work, and learn from those in implementing this collaborative process of our own. So this is very exciting to see a 65% reduction from this collaborative process. Now, this is not easy. It took a lot of arm twisting to get people to come and play in this sandbox. And the reason is because the normal human nature is going to be, I'm coming to the sandbox and my stuff is fine. You're the guys that need to fix your stuff. So it's going to be the manufacturers. They'll say, hey, look, if the airlines would, the pilots would fly them the way they're supposed to, and the airlines would maintain them the way they're supposed to, everything would be fine. And the airlines say, if the manufacturers would build them the way they're supposed to, and the pilots would fly them the way they're supposed to, everything would be fine. What's the problem? And the regulator says, if you just follow the damn rules, everything would be great. Well, everything isn't great. By the way, the regulator also comes and says, ooh, boy, this is a juicy source of information, and if I see anybody going 26 and a 25, I'm going to punish them. Okay, well, if you come to the table, then there's labor, of course. They come to the table saying, I'm going to protect my brothers and sisters no matter what. So if your brothers and sisters overfly Minneapolis by 125 miles, you need to be asking yourself, is that a time to be protecting your brothers and sisters? So this is not a democracy, but everybody has to come to the table recognizing in their enlightened self-interest that if they work together collaboratively, the end result is a win-win, because everybody wins, because everybody's interests are considered in the outcome, and the outcome is optimal for everyone. Now, people don't want to bare their souls in front of the regulator, so that was a huge challenge, having the regulator be welcome to this party. But that was essential to it, because as soon as they start talking about this information from the front lines, the regulator better be there, because if the regulator doesn't guarantee there's going to be protection on how that information is going to be used, absent criminal and intentional wrongdoing, then this program is going to fall apart. These participants are co-defendants in crashes, because if there's a crash, the airline is going after the manufacturer and everybody's pointing fingers at each other. Labor and management, they don't get along oftentimes. They're adversarial. I've never understood this sort of your end of the ship is sinking philosophy. I never understood that. But the point is, these are a lot of segments of the industry that have differing and sometimes competing interests, and getting them to work together in their enlightened self-interest is a huge, huge challenge. And that challenge depends on trust. That's the linchpin to this collaborative effort, is trust. Getting all these players to come together to realize in their enlightened self-interest how the result is a huge win-win for everyone. That's what produced the 65% reduction in fatal accident rate in only 10 years. How does this happen? Not by itself, because you have good leadership to demonstrate safety commitment, but they can't do it in a way that says, no errors on my watch, because as soon as you say that, there will still be errors, but I guarantee the leaders will not hear about it, because they don't want to hear it, because middle management says, hey, I'm not going to tell the boss about this, because the boss said no errors on my watch. Don't tell me about it. So there can't be no errors on my watch. You have to recognize that people will make mistakes. So the issue is not no errors on my watch, but how do we improve safety? And leadership has to be on board with that. They also have to think in us terms instead of you terms, because usually management says, you guys are the problem, and we're going to fix the problem by training you guys even more than we already do, as opposed to, I'm part of the problem too, because I'm the one who creates the circumstances, the rules, the hardware, the software that you use in which you are trying to do the right thing every day. So if it's an us approach, that's much more togetherness versus a you approach, which is very polarizing. So leadership has to look at it as a system thing and not a you thing. Make safety a middle management metric. I talked about that. Engage labor from the outset, because guess who has to implement these programs? Labor. And if they're not on board with it, this can't be management says, hey, labor, I got the solution for you. I know what you ought to do to fix the problem. This has to be labor engaged from the outset to collaboratively identify the problem and develop the solution so that labor has an ownership interest in it, because I assure you that the program will not be completely successful at the outset, it will need some tweaking, and guess who's going to need to do the tweaking? Labor. So if they're not in it from the outset, it's doomed to failure. And then, of course, the system think, that's the whole point of this presentation, it has to include all of the pieces of the system. And then last but not least, the reporting has to be something that people won't feel they're putting this into a black hole, never to be heard from again. There has to be some feedback, some response to it to show that there's some follow-through on these concerns that labor has shown. Now, the potential for this in terms of labor management relations is huge, and I can't even measure it, but I have to think that going from adversarial, which is what labor management relationships so often are, to labor saying, wow, management is actually listening to what I'm saying, and management saying, wow, labor has some really good ideas on how to make things better. This has the opportunity to change this dynamic from adversarial to partners in improvement, and that is huge in and of itself. I have to think that has huge productivity benefits all by itself, not to mention less turnover, better morale, all the things that make the situation better from a safety standpoint. So this is a huge, huge win-win, but it takes good leadership. Now, the regulator has to play a role in this too, because the regulator has to emphasize the importance of system issues in addition to looking at the worker. Now, this is not instead of looking at the worker, because always, always, always accountable is the worker. They will not, this is not get out of jail free for the worker. This is we're looking at the worker issues and the system issues, not we're looking at the system issues instead of the worker issues. So the regulator needs to emphasize it, that the importance of looking at system issues as well as the individual issues. And so they have to encourage people to participate in that system think, and hopefully they will also participate in the system think as happened in this example that I showed with the FAA. And it's very important that the regulator, they're the ones who are in charge of the rules and regulations regarding protection of this information from and about the front line. So the regulator has to be up front showing what the protections are and saying this information will not be used against you absent criminal and intentional wrongdoing, and encourage the other industry participants to do the same. Last but not least, every regulator I've seen out there, when I talk to the enforcement attorneys at the FAA and you ask them, what is your job? Is your job to enforce compliance, or is your job to improve safety? And almost without exception, they will say, my job is to enforce compliance. Well, I would differ with that. I would say that a regulator's job is to improve the management of risk. And the enforcement is just one of the tools, but that is not their mission. Their mission is not enforcement. Their mission is improving the safety in the industry that they regulate. So that's a huge mindset shift to go from compliance, compliance, compliance. Every time I see someone going 26 and a 25, I'm going to beat them up, versus how do we improve the industry? Because there are situations in which the regulation itself is not suitable for the circumstance and needs to be looked at. But if the regulator just says, you didn't follow the rule, I'm going to punish you, versus, I wonder why so many people aren't following this rule. Maybe the rule itself is not such a hot idea. Maybe we ought to revisit that rule. So this is an effort that takes leadership. It takes regulator participation in a very progressive way. This doesn't happen all by itself. So having said that, my time is probably up. Thanks for the opportunity to be here. I look forward to working with all of you, because I think, even though one size doesn't necessarily fit all, I think there are lots of lessons to be learned in other industries, and that's why I give this presentation to nuclear power and chemical manufacturing, and you name it, banks. Even after the meltdown, they came and said, how can we manage risk better? Healthcare, so many industries, these, and I'm not an expert in any of those, as I am not in yours, but I can say we have enough similarities that there are lessons to be learned about what worked and what didn't work, and thanks for the opportunity for me to talk about our industry. Thank you.